Guys, in the today's session that we are required to discuss about something called dimensionality reduction. We can discuss something called a dimensionality reduction. See, the main idea, we have the two different applications for performing this dimensionality reduction. One is PCA and another one is LDA. Okay. Principal component analysis. Number two, LDA, linear discriminant analysis. Okay. Out of which we are going to discuss about the PCA now. Principal component analysis. Okay. Now, see, the main idea of this particular principal component analysis is to reduce the dimensionality of the data. Okay. Why? Because the data set, whatever the data set that we do have, will consist many variables which can be correlated to each other. This is the main problem that we will get generally. Variables correlated to each other. Okay. We will use the PCA for dimensional reduction data set. Okay, this will be used for a dimensionality reduction for a data set. So now, so generally we understood that whenever we have the variables which are correlated to each other, that variation will be definitely reflected towards the data set. See whether they might be highly correlated to each other or whether they might be very lightly correlated to each other. Definitely there will be an impact. So we need to first, in order to dilute this one, what we need to do, we need to transform the variables to a new set of variables. Okay, so which are generally called as a principal components. So what we can do here, we can achieve this one by transforming the variables to a new set of variables. Okay, which can be called as principal components. Okay. Understand? So guys, here let us see one example with the principal component analysis program algorithm. How many of you can tell me about what do you mean by scaling? Why do we do it? I have explained you before covering the classification algorithms. I have explained you about the feature scaling and the confusion matrix. What do you mean by scaling? And I don't want about the confusion matrix. Why do you scale? Hmm? Everyone, why do you do the scaling? Huh? Exactly, for the normalization purposes. Really good. That's good, Suresh. So here, what I'm trying to do, very first thing that what I'm trying to do here is wine.csv. I do have a one particular data set called wine. Okay. So what I'm going to do, I'm going to explore this wine data set where you do have the how the customers are customer segment, three types of customer segments, and I do have the different wines here. In a wine, how many different types of ingredients would be there inside? Okay, color intent and everything. It's all a combination. How much is alcoholic percentage? How much is malic acid percentage? How much is an ash? All these things. Okay, so this kind of customer segment or trying to get this one, something like this. Okay, I have some wine data set. Okay, on which that I'm going to build this one. See, the very first thing that we need to scale the data that we do have with this. Okay, and before that, once after that we do split the data. Here we need to see, I have taken the all predictors 0 till 13. 13 is exclusive, whereas that 13 is nothing but the target value. Okay, and here you could see 1. Okay, here is the 13. Whenever I consider the first one is 0, right, as per the Python, so then you will have 14. So first one starts with 0 and 14th one ends with 13. Okay, so you could observe. So here, splitting the data and now scaling the data. Okay. Now, I have to import the principal component analysis function from the scikit-learn. We have something called decomposition. So I'm trying to use the principal component analysis. I try to segment two different components, two components. So n underscore components refers to the two components. I told you what do you mean by components, principal components. The variables, whatever the transformation that we are trying to apply to the variables into a new set of variables can be considered as a principal components, as I told you. Okay, so here, this is all about the technique that we are trying to apply on the different wine bottles. Okay, how their ingredients are, and who are all the customers buy that particular bottles and all stuff. So, one second, guys. Okay, guys. So now what we are trying to do is this data set, we are trying to first scale it, okay, by using the relative scaling or using the standard scaling. So here, as a layman understanding, what we are trying to do, we are trying to summarize the data where all the wine bottles which are having a different attributes, okay, like the color or the alcohol percentage and all stuff. But here, there is a lot of redundancy. Okay, redundancy will come up in the data that we are trying to analyze from many of the individual variables. Hence, we just need something in order to summarize this with the less characteristics. Okay, so we can apply, see, we can try principal component analysis, which can be supplied to the user with a low dimensional picture. Means the low dimension means nothing but we are trying to observe the way that how we are transforming this principal component analysis, reducing from the two-dimensional to one dimension or three-dimensional to one dimension. Okay, means we are reducing the, we are trying to reduce the dimensionality. What do you mean by dimensionality? Number of variables we are having in a data set or number of features that we are having in a data set or otherwise number of columns in a data set. We can consider all these things as a dimensionality, reducing dimensionality reduction. What do you mean by correlation? It is about the relation between the two different variables. Okay. So now let us try applying this part. We need to first normalize the data here on this 2D data set, whatever that we do have. Applying the PCA so that we could come out with the best transformation of the data. Why? Because I am trying to implement the logistic regression for this data. So let me just check the confusion matrix that I do have it here. So how do we identify the performance of this model? By looking at the confusion matrix, we can clearly understand the performance of this model. You could see this is the three-dimensionality data. Okay, add up all the dimensionality stuff. Why? Because once of the dimensionality was done, this is the confusion matrix has given us the values. Otherwise, this is not something like that. Understand? So you can try making up 14 plus 15. How much is it? 29 plus 35. 35 divided by 36. How much it is going to be? It's nearly going to be 90 percentage, nearly. Okay, more than 90 percentage. Really good model. We can try understanding about this one. So here, applying the visualization for the training data set. Okay, logistic regression. Three different segregations. Okay, red color customers, green color customers, okay, and blue color customers. Understand? Guys, did you understand about this part? Any questions so far? See, nothing but before we are going to do this, see, before we are going to apply some sort of understanding about the See, if you are going to apply the logistic regression for the same data set, you are not going to get the this much of accuracy or the efficiency of the program or the algorithm. Okay. So hence we need something like this. And the very second thing is, I just wanted to give you some understanding about the model selection. We have something called XG boost. For this, what we are going to try is, we are trying to understand about something called a churn modeling. Generally, we will try to use understanding about the customer segmentation. So the churn modeling, we do have the customer ID, row number, surname, credit score, geography, gender, okay, number of products that he has purchased, has credit card or not, all these things. Okay, so what is the estimated salary? Is exited or not? Okay, something like this. So in order to understand this one, definitely we are required to understand what exactly the XG boost is. See guys, XG boost is something just like a machine learning algorithm, okay, where it will be implemented for understanding the decision trees mostly. In order to apply the speed and the performance for one particular algorithm, we can rely on this particular XG boost. XG boost. Okay, and how we are going to get out this one? We need to understand first of all what exactly this XG boost is. XG boost means extreme gradient boosting. Okay, let me write out here. XG boost means extreme gradient boosting. Okay, so in order to give the best performance, we will apply this one. So this is something just like implementation within the machine learning applications. Okay, so this is going to be a one of the software library that we could get for in whatever the programming languages that you are going to take. So what is the main feature of this one? First of all, it will offer the multiple advanced features where you can kickstart your decision trees or the random forest kind of stuff to run like anything else. So the main features within this particular extreme gradient boosting is consisting with gradient boosting, stochastic degradient boosting, regularized gradient boosting. Okay, so by implementing of this one, it will have a three main forms of the gradient boosting within itself. Okay, so where this is all about parallelization of the execution. Why we are using the XG? If someone is going to ask you the interview question, why do we need to use the XG boost? XG boost will be implemented with any sort of the machine learning project just because to improve the execution speed and the model performance. Okay, here the XG boost is really faster when it's compared to the other implementations of the gradient boosting. Okay, so now let us try understanding about this XG boost by using one such a sort of example. Okay, and also we can think that this is one of the ensemble technique that we have discussed in the during the decision tree algorithms and all stuff. So I need to first transform the data, then splitting the data. So what is happening, I do have a lot of categorical data where I'm trying to encode that using something called a label encoder and the one hot encoder, which we have already gone through this one while we are working on with the classification. Okay. So we are trying to use something called the XGB classifier from the XGBoost. Okay, there is no module named XGBoost where I just wanted to install that. So let me try pip install XGBoost. Okay, now let us try one more time. Now let me rerun these things. Maybe I am required to restart this part. Let me restart, otherwise. So guys, somehow like it is making the application crash when I'm trying to execute this XGBoost directly from here. The kernel is getting died. I will just solve this issue by tomorrow and I will just re-show you. I will try to show you this one again. And also I will just cover the parallelly natural language processing and the neural networks tomorrow. Okay. So give me some time. I will just fix this by tomorrow. It's unable to process this XGB classifier. Okay. Thank you guys. We'll meet you again tomorrow. Bye.